Hello. So for my prompt, I decided to talk about the different types of point mutations. So to start off here, I have written out is our coding strand here in that 5' and 3' direction. So it is our coding strand. And I divide it into our different codon segments. I think it's easier to illustrate the different types of point mutations, and it's easier to see in this kind of simplified format. So to start off, I'm talking about transitions and transversions because those are something that I'm going to mention throughout the video. I think it's easier to explain at the start. So transitions are changes from purine to purine and pyrimidine to pyrimidine. So it'll actually maintain the same number of rings in the nitrogen space at either 1 or 2. And example of this could be A to G or G to A, and T to C or C to T. And transversions are the opposite, so it could be purine to pyrimidine or pyrimidine to purine. So actually change the number of rings. So you can go from 1 ring to 2 rings, or 2 rings to 1 rings in your nitrogen space. So examples of this could be G to T and G to C. So for our first example here, we have missense mutations, or non-synonymous, and these will be changes that change that amino acid, which can inhibit the function or change that protein function. So we're focusing on our second codon group here. So we have a TGG. I'll be changing it to a CGG. So T to C is a transition change. And we're actually changing a tryptophan to an arginine, so that could alter that protein functionality. So we're making a different amino acid. And our second example is our nonsense mutations. So this will actually make a stop codon where one wasn't originally, so it could shorten that sequence potentially. And we're going to be focusing on our fifth group here. So TGC, that does not code for a stop codon. So we're going to be changing TGC to TGA. So a C to A change is actually a transversion change. And since we're changing this guy, cysteine, to a stop codon, and that will be our nonsense. And then for our third example, we have readthrough. So this will change a stop codon to a different amino acid. So the amino acid and protein chain will actually be longer than intended. So at our sixth position here, we have our stop codon TGA, which will end up being the UGA stop codon. So we're going to change this TGA here to a CGA. Since we're going T to C, that's a transition change. And we're changing this stop codon to an arginine codon. So that will make that amino acid sequence longer. And for our last example, we have silent mutations, which will code for the same amino acid despite the base change. So at our fourth position here, we have GCT, will end up being the GCU codon and code for alanine. And then we're going to change this GCT to a GCG, which also codes for alanine here. And so we're going changing T to G, we have a transversion change here. So this won't actually change the amino acid, it just changes the base here.